Welcome everyone. Today we are going to talk about bit manipulation. So this is the very first video of bit manipulation where we will understand what is bits and what is the importance of bit manipulation. Going forward in the next video we will talk about what are the bitwise operators which we use to do bit manipulation. So today we are diving into the fascinating world of bit manipulation in embedded system. Let's explore how mastering bit level operation can supercharge your programming skills for embedded devices. First, let's understand what is bits and then we will move forward understanding bit manipulation. So in our machine or embedded system, everything operate on 1 or 0. Whether it's controlling sensor, managing flags or processing data, it will comes down to how we are manipulating these binary elements. Now let's understand bit manipulation. So bit manipulation is the art of directly working with these individual bits, zeros and 1. So in a manner that allow us to perform powerful operation at low level basically. For example, you have this bit 0 as 1. So now if you do AND operator with 0, this will gives you an output 0. In the same way, you have this bit 0, you perform OR operation, this will gives you the output 1. So to do this kind of bitwise operator on individual bits of a variable is called bit manipulation basically. Instead of that, let's say generally we have our variable integer variable. Let's say the you have an integer variable which has the value 10 and you have another integer variable which have value 20. So generally what operation we perform on these variable is, let's say if you are doing addition of these two variables, so you will be doing variable plus variable 2 which will give you the value 30. So now in the same way, instead of having this plus minus or we can say the addition subtraction, we have bitwise operator basically. We have AND operator, we have OR operator and we have XOR operator. So we have bitwise operator basically which we generally perform or we use these operator to perform bitwise operations on this bits individual bits of a variable basically. So this art of manipulating these bits by using this AND or XOR and bit or we can say the bitwise operator is called bit manipulation. Okay, so in embedded system basically where we have always constraint on the resources, like generally we have very less memory in embedded devices. So bit manipulation basically play a pivotal role in optimizing memory uses and improving the efficiency, right? For example, let's say you have a hardware machine basically. So you have some machine or you can say some embedded device. Okay, so this device for this device basically you have to maintain few states basically. So the state possible can be on, off, sleep and suspend. Okay, so one way of doing this is like if you don't use the bits and the bit manipulation strategies, one way of doing this is for each of this flag you are going to use one integer variable. Let's say you are going to use some integer variable, integer and then flag on, so just to tell whether this machine state is on or not. Okay, and other variable you can use like flag off to tell whether your machine is off or not, and the next variable you are using flag sleep to check whether your machine is like in the sleep state or not. Other variable you are using for suspend basically to tell whether your machine is in suspend state or not. So by using individual integer for each flag, you are consuming 32 bit if you are working on 32-bit machine. So an integer will be consuming 32-bit just to represent a single flag basically. And let's say if you want to represent all these flags, then you have to consume 32 multiplied by 4, which is like 128 bits of memory you are consuming just to represent these four flags. But now let's say if we use bits representations for these flags, how we can save memory. So for that, let's say if we are create one structure, okay, and instead of using complete integer variable, we are going to use just a single bit to represent one flag. Sorry. So what does this line means? So this line means is like you are only using one bit, because anyway you have to just tell whether your machine is in this particular state or not. So for that you just need to store value 0 or 1. So one bit is enough to basically store these two values, which is like 0 and 1. So instead of using complete 32 bit just to represent this value 0 or 1, you are just using one bit, which is enough for you to maintain the state of this particular, whether it's flag on or flag off, right? And in the same way, for flag off, you are again using a single bit, okay? Then in the same way, for sleep also, you are using a single bit. In the same way, you will have suspend state, that also will be used a single bit. So now you are representing these four states using only the four bit flags basically. So if you will check the size of this structure, so let's say if you will do the size of this structure, so this will, like on a 32-bit machine, I'm assuming it will doing some padding for the alignment, so it will be the 32 bits of size. So in the previous case where you were not using this bit manipulation, so you were consuming 128 bits just to represent these four flags. But now you are just using 4 bit, but because of this alignment, the size of the structure is giving 32 bits. So now you are using 32 bits just to represent these four flags basically, and each bit of this 32 bit basically can be used for an individual flags. What does it mean? It means right now we have only four elements into this structure. You can add more elements also into this structure. You can add total 32 bit element on a 32 bit machine. So this 32 bit element will be representing 32 bit flag. So by using just 32 bits, you can represent 32 bit 32 individual flags basically. So this is how you're saving memory. In without bit manipulation case, you were consuming 128 bits, but now in the case of uh, bit manipulations, you are using only 32 bits of memory to represent the same flags. So this is the basically benefit of using the bit manipulation. And other scenario where we use bit manipulation a lot, and why bit manipulation play an important role in embedded system. So being an embedded system engineer, you will be working on obviously on the devices, and how you control your devices or how you control your embedded system products basically. So obviously you will be configuring the hardware registers of that particular registers hardware register of that particular device basically, okay? And then those hardware, let's say if you take an example of 32-bit machines. So in 32-bit machines, your hardware size will be of 32 bit, okay? So this is a 32-bit register for your device basically. So each bits represent some particular state or configuration of this particular device, right? So each bit of this register has their own significance. So to configure this device state, or to configure this particular device registers, you need to play with individual bits of your hardware basically, or your registers basically. So to perform, maybe to reset this particular bit, or to clear this particular bit, or to toggle this particular bit, you need to again use bit manipulation. So that is why bit manipulations play an important role in the life of embedded system engineer, because every time when we are going to deal with some hardware registers, definitely we are going to play with individual bits of that particular hardware registers. So bit manipulations will be used a lot. So that is why bit manipulation play an important role whenever you go for any interviews in for the post of embedded systems basically. So that's it for the bit manipulation. In next video we will talk about bit operators, how bit manipulation works using these bit operators. So if you found this exploration of bit manipulation useful, hit that like button and subscribe for more deep dive into embedded system and programming techniques. Also feel free to share your thoughts and questions in the comment below. Until next time, happy learning.